Sockets to HTTP. I can already hear it. It's 2020. Haven't we solved the network server problem yet? I was working on a project recently, and this is exactly what I had hoped. I went to GitHub and looked for an open source HTTP C++ single header library file. But I'm a hopeless craftsman, and it didn't actually do everything I needed it to. So, yet again, another network library. What to look for? Minimal, easy to extend protocol interface. This library implements a TCP and HTTP protocol. Memory map direct to socket streaming. One less buffer, two less copies. Multi-threaded, automatic multiplexing. High throughput socket wait technique. Modern C++. Cross-platform, unit tested, open source. I actually wrote this server years ago, and the reason why I dusted it off to use it again is because it lets me implement any protocol that I'd like on the network server. HTTP, TCP, WebSocket, whatever. And also because of the automatic multiplexing. If you want high throughput, you need multiplexing. And having the server handle all those details for you, yeah, it's pretty nice. Let's take a bird's eye view of the architecture. The client is acquired by the listener and dropped into the connection pool. The connection pool is serviced by a reader thread or multiple reader threads. The reader thread, when it receives a message, drops it into an event pool. That event pool invokes a write, and that write returns to the client. Not every connection has a thread, but you can configure how many threads service connections. The event thread pool is disconnected from the I/O thread pool. Thread priority is given first to the writer, then to the events, and then to the reader. Automatic multiplex. So, as we have requests streaming in, these requests are handled by our event pool. Each request can be handled in parallel. The multiplexing ensures that the responses are sent out to the client in the order that they are expected. Connections can operate in streaming or buffered mode. Streaming operates better when dealing with large amounts of data. Buffered works better when dealing with high latency. Here is a segment of code from a unit test. Using the make HTTP server helper function, we handed a port and a lambda. The lambda takes the connection, the request, and the write ordering handle. Instead of using regex or some type of string comparison, we're actually using a switch. This is made possible by a constant expression function, which converts a string into a hash. It is superior to a string compare or a regular expression, if mean and lean is the goal. We easily account for case sensitivity of our HTTP action. As you can tell, this server echoes the body for the echo endpoint. Any other request will return 400.